Hi everyone, in this video we will learn monitoring of flow rate of gases and how to control it. That is flow rate measurement and control of gases in a fermentation. How would you monitor the flow rate of gases during a fermentation? There are two instruments or devices with which you can do that. One is rotameter. Another is thermal mass flow meter. We will study each one of them in detail. Let's see rotameter first. Rotameter is an example of a variable area meter. It's very commonly used. It consists of a vertically mounted borosilicate glass tube with an increasing bore. That is, it's a tapered tube. You can see the diameter of the tube is not same from top to bottom. The diameter here is different and the diameter here is different. And this vertically mounted glass tube, the tapered tube, consists of a free moving float. This float may be a ball or it may be a hollow thimble. Thimble is a metal or plastic object that is worn on fingers to protect the fingers while using sewing machine. So rotameter consists of a tube and a float. Now this rotameter is placed in the path of the gas or the liquid for which you want to measure the flow rate, and this blue arrows you can see the direction of the gas or the fluid in this case. Now it's a free moving float, so this will move because of the flow of the gas or the liquid. Now the rotameter's operation is based on the variable area principle. That is, the fluid flow or the gas flow will raise a float in a tapered tube, increasing the area for the passage of the fluid. Okay, so this fluid flow or the gas flow will raise this float, increasing the area for the passage of the fluid or gas. So you can see as the flow rate increases, the area around the float must increase. The greater the flow rate of the gas or liquid, the higher the float is raised. So the float will move up and down, and when it balances or come to equilibrium, you will get a reading because this glass tube is graduated, so you will get the flow rate. Is this rotameter accurate? Yes, the accuracy depends on having the gas at a constant pressure, but errors up to plus or minus 10% of full scale deflection are quoted. And the errors are greatest at low flow rates. Now, ideally, these rotameters should not be sterilized. For example, the air that you introduce into the fermenter via sparger. Now, the air is sterilized using filters. So, if you want to measure the flow rate of that air or gas, you have to keep the rotameter between the gas inlet and the sterile filter, because the rotameters ideally should not be sterilized. So when you keep the rotameters between the gas inlet and the sterile filter, rotameters may tell you the flow rate of the gas, and then you can sterilize that air and it may be allowed to enter the fermenter via sparger. If you are not satisfied with the glass tube, metal tubes can be used in situations where glass is not satisfactory, and the float position is determined there by magnetic or electrical techniques, but this provision has not been normally utilized for fermentation work. Rotameters are available in different sizes, and you must be wondering that if we are studying the flow rate of gases, why I am mentioning in the rotameter that the fluid or gas, because rotameters can be used to measure the flow rate of liquids as well, provided that there are no abrasive particles or fibrous matter present in the liquid. So they can be used to measure the flow rate of gases and liquids both. So first was rotameter. Let's move on to the another device or instrument that can be used to measure the flow rate of gases, that is thermal mass flow meter. Now, if you need more accuracy, you can go for these thermal mass flow meters. They have been utilized for a range of flow rates, and they employ the thermal dispersion principle. They work on the principle of measuring a temperature difference across a heating device placed in the path of the gas flow. So this is the structure, or I can say a illustration of a thermal mass flow meter. You can see there's a heater. Now this heating device is placed in the path of the gas for which you want to measure the flow rate. Now, as the gas will flow, the gas flowing here will absorb this heat, and the heat absorbed by this gas is directly proportional to its mass flow. Now this gas which is flowing will absorb this heat from the heater and will try to cool the source. Now as the flow rate increases, more heat will be absorbed by the gas. So how much heat will be absorbed by the gas, that depends on what is the flow rate of the gas. So if the gas is moving at a very high flow rate, more heat would be absorbed. So to find out the flow rate, you should know how much heat was absorbed by this gas when it was flown over this heater. So this can be found out by using temperature probes, such as placing thermistors upstream and downstream of the heat source. You can see there's thermistor T1 before this heater and there's thermistor T2 after the heater. Now these thermistors can be inside or outside the pipe, okay, and you measure the temperature difference across this heating device placed in the path of the gas flow, because as the gas will flow and absorb the heat, there would be temperature difference which the temperature probes will measure. And as I said, how much heat would be absorbed by the gas depends on the flow rate. You can calculate the flow rate. These are very accurate instruments giving you an accuracy of plus or minus 1%. And we have studied the two devices or instruments here. One was rotameter, another was thermal mass flow meter. These both can be used for the monitoring the flow rate of gases. Now, how would you control the flow rate of gases? Now, control of gas flow is usually by needle valves, but often this method of control is not sufficient, and it's necessary to incorporate a self-acting flow control valve, and such valves are available on the small scale as well as for larger scale applications.